Okay, so in this lesson I'm going to look at just another example of a word problem with differential equations. In this case we're going to be dealing with volume, and this has been the kind of pattern over more recent years. They tend to put fewer kinematics questions in, introduce different kind of things, even financial maths and population growths and a few things like that. So I'm going to read through this question, note a couple of things, and then go through the solution. The solution's pretty simple actually, but because it wasn't about acceleration and velocity and position, displacement, that threw some students. Okay, so you've got to be prepared for anything to come up and be able to interpret the information. The question says water flows from a tank at a rate proportional to the volume of water remaining in the tank. The tank is initially full, and after 1 hour it is half full. How many more minutes will it be at 1/5 full? Just to, before I go through the solution, let me just insert page here before and just mention a couple of things. We'd say the two variables x and y are in a direct proportional or proportional. So they're directly proportional if and only if x over y is a constant. Okay? So in other words, if x is some constant multiple of y, well then we have a proportional relationship. Okay, so that's what proportional means. So it's saying the water flowing from a tank, that rate at which that happening is a constant multiple of the actual volume of water in the tank. So if I let V equals the volume, well then we'll talk about the rate at which that is changing. The tank is initially full, and after 1 hour it is half full. After how many more minutes will it be 1/5 full? So I'm going to start my process of translation from English into our language of mathematics. So it says water flows from a tank at a rate proportional to. So the rate at which, proportional to the volume. So it's saying the water flowing from the tank is proportional to the volume of water remaining in the tank. So I'm going to let V equal the volume of water, and the rate at which it's flowing from the tank will be some constant multiplied by that V. So the rate at which it's flowing is the rate of change of volume with respect to time. That's the rate at which it's flowing from the tank. The other thing is, because it's flowing from the tank, that rate of change is going to be negative. Remember, volume is always positive, so it's going to be some negative times a constant times V. Okay? That's the first thing. The second part says the tank is initially full, so the volume is equal to, well, we don't know what the volume is, so I'm just going to set it as one full tank. So the volume is equal to 1, my units are full tanks, when T is equal to 0. That's another piece of information. The volume is equal to 1 full tank when the time is equal to 0, and the volume is equal to 1 when the time is equal to 0, and the volume is equal to, well, it's a half tank, so 1/2 of a tank. When 1 hour has passed, I'm going to say T is equal to 60. Why am I saying T is equal to 60? Because it says how many more minutes will it be 1/5 full. So our question is find T when V is 1/5 of a tank. So that's the way I'm interpreting this. Notice my units for volume, I'm using tanks. Okay? So here's my equation. I'm going to separate and integrate. So dividing on both sides by V, we get 1 over V is negative K times, we're going to multiply on both sides by dt, and then we're going to integrate, taking the antiderivative. On the left hand side, that's going to be the natural log of the absolute value of V. Let me just put those brackets in for the moment, but I'm going to remove them because V is volume. Volume is always positive. The absolute value of a positive number is always positive. So I don't need to confuse things by putting in my absolute value brackets here. And it's just going to be the natural log of V is equal to negative K times the antiderivative of 1 with respect to T is T, plus the constant of integration. So there's my general solution. I'm going to come up with a particular solution. Again, it says, you know, what are my initial conditions? Well, it says that V is equal to 1 when T is equal to 0. Remember, my units for volume are tanks, and my units for time are minutes. So V is 1 tank full when T is equal to 0 minutes. So subbing in there, we're going to get the natural log of 1 is equal to negative K times 0 is just 0 C. The natural log of 1 is 0, so we get C is equal to 0. Fairly straightforward, which of course means my particular solution is just the natural log of V is equal to negative K times T plus 0. That's the first part. I want to think about this constant of proportion. The second piece of information, you know, in my conditions here, it says that the volume is equal to 1/2 of a tank when the time is equal to 60. So I can substitute these things in. So natural log of 1/2 is equal to negative K times 60. And from that I can establish that negative K is just going to be equal to the natural log of 1/2 over 60, dividing both sides by that. So now my particular solution, natural log of V, is negative K. Well, negative K is the natural log of 1/2 divided by 60 multiplied by T. I'm trying to find T. When V is 1/5. So I'm going to make T the subject of this equation. T is going to equal to, I'm going to multiply both sides by 60. And I'm going to divide on both sides by the natural log of 1/2. Okay, and that will tell me my time. So T is equal to 60 times, let me actually go back here. I'm just going to be very particular how I write this. So it says, after how many more minutes will it be 1/5 full? Well, when the volume is 1/5, T is going to equal to 60 times the natural log of 1/5, all divided by the natural log of 1/2. Okay, so we're nearly there now. It's just finishing this last little bit off. And that's, you know, work that I can do in my calculator. And in fact, I can't really do it without my calculator here. It's not really something that I'm going to be able to do. So my fraction is going to be 60 times the natural log of 1/2 over, of 1/5, I should say, over the natural log of 1/2. So T is I'm getting T there to be I'm going to say 139 point, I'll just round it off, 36. And my units there are minutes. So after 139.36 minutes, the tank is going to be 1/5 full. Okay? Now I'm just going to go back and just check something in the question. It doesn't say how many minutes will it be full. It actually says how many more minutes and how many more minutes after an hour. So it tells me an hour it's half full. So how many more minutes, you know, that word in there, easy to miss it. How many more minutes? Well, all I want to do is say, well, how many more minutes after 1 hour is this? So I'm just going to say 139.36 minus 60. That's going to work out as 79.36 minutes. Okay? And in fact, probably even better to write in 79.36 more minutes. And that's the length of time it's going to take. after it's half full to get 1/5 full. Okay, so that's an easy thing to miss. But the process, again, fairly straightforward. Get your equation. That's often the hardest thing, translating from English into our mathematical language here of calculus. Antiderivative on both sides. Find your general solution. Use your initial conditions to find your particular solution. My particular solution here, however, there's a constant I don't know. There's more conditions given. I use those conditions to find a value for that constant. Substitute it back in. Remember, that's negative k I found there, not k, so that goes straight in for negative k. Natural log of a half over 60 is negative k, so that goes in for negative k. And then solve for t. Make t the subject of the formula and plug in 1/5 for v. Calculator work. Bob's your uncle. Okay, so practice more and more of those.